All right, there's a lot of words up here, and I just don't care. Put your hands in the air like you just don't care. Yeah, I just don't care. Let's jump right to here. Let's sketch y equals 2 sine x. Well, there's a couple of things here. Notice what the a value is. First, I'm going to sketch this. I'm going to sketch y equals sine x, to be honest with you. I'm going to sketch that first. And then, in a different color, I'm going to sketch this. Okay? Now, one of them is a vertical stretch of the other. So one of them should go up higher than the other. So the first one, we should know a little bit about the sine curve. We should know that when x equals 0, sine of x equals 0. And you know that when sine equals 90, it goes to 1. When sine equals 180, it comes back to 0. When sine equals 270, it's going to go to negative 1. And when sine equals 360, it's going to go to 0. You should know that. And if you want to write it out as a list, be my guest. Here's another way to write it out. I put an S to stand for sine. And 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So I've basically said if I'm going around and around and around, it would be 90 degrees, starting from my initial arm, then 180, and blah, blah, blah. And if you know something about the sine curve, then you know that the sine curve starts at 0, and it goes up to positive 1. Then it goes down to 0 because there's nowhere to go from its maximum but down. Its minimum is negative 1, but you got to go through 0 before you hit that, and then you got to come back up to 0. So this little diagram here is actually all the same information as this chart. If you'd rather remember it that way, be my guest. But in either way, I'm going to come over here and I'm going to say, okay, this is going to be 90 degrees. 1, 2, 3. I made that 90. Now, I have a habit of doing that because that way I can subdivide 90 degrees into 30s if ever I have to. So I could go 30, 60, 90. Okay, so I normally go 3 over to get a 90. And then what I would do is go 1, 2, 3, so that would be 180. 1, 2, 3, so that would be 270. 1, 2, 3, and that would be 360. So I usually space myself out so that if I need to subdivide, I can. Now, the next thing I need to do for this curve, notice what my maximum is. My maximum is 1 and my minimum is negative 1. And again, you should kind of know that if you know anything about the sine curve. So let's make this 1. Let's make this negative 1. Now, I'm being kind of sneaky because I know later on I'm going to change that, right? That's a vertical stretch. Later on, I'm going to have to do a vertical stretch up by a multiple of 2. So this is actually going to have to go all the way up to 2 and down to negative 2 when I sketch the next one. So I'm being a little sneaky. I didn't use all of it up. Okay, so let's sketch the first one. Sine of 0 equals 0. 90 goes to 1, back down to 0, down to negative 1, back up to 360. Look at how I do this curve. I start up here and I come down. I start up here and I come down. I start here, I go down. I start here and I go up. You have to get a nice curve. If you don't have a nice curve, I'm taking marks off. Okay? It has to be nice and curvy. Okay. Now, guess what I just graphed? That's y equals sine x. That's it. It's one complete wavelength. It's between 0 and 360 degrees, and it's gorgeous. Just look at it. It's beautiful. So what am I going to sketch next? A vertical stretch of that. So each of the points is going to be moved twice as far away from the horizontal axis as it used to be. Now, if I move every single point, that's going to be really tedious and boring and a pain in the butt. But if I just move the important points, so would this one move? The distance from this point to the horizontal 0. So times it by 2, it doesn't move. This one moves though. It goes up that high. That one doesn't move, but this one moves. It comes down twice as low. So your new curve, and again, it needs to be curvy. Oh my Lord. Look at that. It's gorgeous. And that is the new curve with a vertical stretch. By a multiple of 2. Now, that's a perfect way to do this, and I'd give you full marks for this. There's another way that people like to graph, and it's called point notation, and it's particularly popular at this school. So when you go into grade 12, chances are your teacher's going to use it a whole bunch. I'm kind of blah. It's cool and all, but it's not the only way. So this is one way. Here's what the notation would look like if we're going to do point notation. And what you do is you start off by saying, well, the original is going to be theta sine theta. But that's going to go to theta 2 sine theta. So this is point notation. And this is your original curve. And this is the new curve. So in this case, the original curve is y equals sine theta, right? Y equals sine theta. And in this case, the new curve is y equals 2 sine theta. So what you have to do is you have to know all of your first points, your critical points, if you will, those important points. And what are they? 0, 0, 90, 1, 180, 0, 270, -1, and 360, 0. Those are your important parts of the sine curve. And like I said several times today, well, only once on the video, but trust me, several times today, these are, you need to know these, right? If you know sine, you know these. So look what this says, though. This says that all those points are going to be changed into having the same theta as you had here, but instead of sine theta, it's going to be 2 sine theta. So now it's going to be 0, 2 times 0, which is 0, 90, 2 times 1, which is 2, 180, 2 times 0, which is 0, 270, 2 times -1, which is -2, and 360, 2 times 0, which is 0. And this, ladies and gentlemen, is what we very quaintly call point notation. Sometimes they call it mapping notation. And that goes back to, remember when we talked about mapping diagrams? They look like this. They took something from one term over to the other. So that's why they call this a mapping, because they see the little arrows there. And what you would do is you would then just plot these points. So you would plot 0, 0, which is here. You would plot 90, 2, which is there. You would plot 180, 0, which is there. 270, -2, which is there. 360, 0, and then you would just connect those points, and you'd get the exact same curve now, wouldn't you? So what's the advantage of point notation? You don't have to do the first curve to know what the original looks like. That's the advantage, I guess. But they're both excellent, and they both have their points. If I was programming a computer, I would do this. If I'm just doing it myself, I kind of like drawing the first one and then drawing the second one. It all depends what you want to do. Okay, so I'm going to stop that video here, and we'll be right back.